Hi everyone, this is the first in a two-part video about solving simultaneous equations. The first method we're going to take a look at is substitution. Now, what is a simultaneous equation? If I have an equation such as 5x plus 7y equals 11, then it's very difficult for me to be able to solve for both the variables x and y using just this one equation. Therefore, with the help of a second equation, I will be able to do this, and that's when the idea of simultaneous kicks in. Now let's take a look at how we can solve these equations. The first example I have here is x plus y equals 1 and x plus 4y equals 6. So substitution, the concept is basically using information from both equations to solve for one variable first, and then substituting the answer we get to find the answer of the other variable. So if I take a look at just the first equation here, we have x plus y equals 1. Now if I want to solve for y first, then I have to get x alone by itself. So in order to do this, I can get x equals, and then if I subtract y from both sides, so I subtract y from both sides, and this cancels out. So that'll give me x equals 1 minus y, right? So then in order to solve for y, I can simply take this value of x and plug it into the x here. And if I do that, I get 1 minus y plus 4y equals 6. This part of the equation stays the same. So what is actually happening is by doing this, I'm getting the same variables in the equation. And if I have just one variable in the equation, then it's quite easy for me to solve for that. Here I just combine like terms, so positive 4y minus y gives me positive 3y, and then the plus 1 stays, equals 6. And I want to be able to subtract the 1 from both sides, so I can get 3y by itself. If I subtract 1, that gives me 3y equals 5. And then to get the value of y, I divide the equation by 3 on both sides, and that gives me y equals 5 over 3. Now with this value of y, I can substitute that into either equation 1 or 2. And if I choose to go with 1 because it seems a lot simpler, then I can go x plus, and then instead of writing 5, I just write 5 over 3. So x equals 1, and to get the answer for x, I subtract 5 over 3 from both sides of the equation. So I have to subtract 5 over 3, and these cancel out, and that gives me x equal 1 minus 5 over 3. Now 1 can also be written as 3 over 3, so x equals 3 over 3 minus 5 over 3. So x equals negative 2 over 3. Okay? So these are the values we got for y and for x. And in order to verify the answers, we can substitute them into the second equation here. So we have x plus 4y equals 6. So I can say negative 2 over 3 plus 4 times 5 over 3 equals 6. Well, it should give me 6 if the values are correct. And negative 2 over 3 plus 5 fours are 20 over 3 should give me 6. 20 minus 2 is 18 over 3, which is 6. Therefore, our answers are correct. Let's look at another example here. If I have a plus b equals 14 and 2a minus b equals 1, then again, I can take my first equation, a plus b equals 14, then I can get a alone, and to do this, all I have to do is just subtract b from both sides of the equation. So that will cancel out, and it gives me a equals 14 minus b. And I plug in this value of a into this equation here. If I do that, I get 2 times 14 minus b. And then the rest of that stays the same, minus b equals 1. So 14 times 2 is 28 minus 2b, and open brackets minus b equals 1. 28 minus 3b equals 1. So I'm just adding like terms here. Minus 2b minus b gives me minus 3b. Now I want to keep this variable term on this side. I want it to be alone. So I'm going to subtract 28 from both sides of the equation. And that gives me negative 3b equals 1 minus 28, which is negative 27. So the negatives cancel out. And that's because all I'm doing is divide by negative 1. So the negatives cancel out. And this leaves me with b equals 27 over 3 now, because the next step I'm going to do is divide both sides of the equation by 3. Sorry. And that gives me a value of 9 for b. Okay, and now all I want to do is substitute this value into either equations. If I choose to go with the first equation, because again, it's simple, then I get a plus 9 equals 14. So a is 14 minus 9, just subtracting 9 from both sides. And a gives me 5. Okay, so you could check the values again by plugging them into the second equation. So 2 times, and for a we got a value of 5, minus our value for b, which is 9, and that should give me 1. Right, this is not 11. This was the arrow mark I made over here. So yeah, it should give me 1. Okay, if we did it right. So 5 2s are 10 minus 9, and that indeed does give me 1. So we can say that our values are correct. So this is basically how we solve using substitution. The second part is going to talk about solving simultaneous equations through elimination. So make sure you check that out too. Thank you.